We're going to continue with the theme of polynomials, and this time we're going to look at polynomials with larger exponents. So you've been working with linear equations or linear functions where x is just to the first power, and we've been working with quadratic functions where x is to the second power. Now obviously there are a lot more functions out there and they can have any power of x. So we're going to look at one particular function. Function of x equals x to the fourth power minus 9x to the third power minus 2x squared plus 7x minus 4. So we're looking for the term with the largest exponent, and it's the fourth power on x to the fourth power. And when we're working with these polynomials, we like to have them in order from the largest exponent on x to the smallest, and this one is. And what we're going to do with this function is try different values for x. We're going to try putting 5 in for x, so we're going to be doing 5 to the fourth power minus 9 times 5 to the third power minus 2 times 5 squared plus 7 times 5 minus 4, and we're going to see what value that gives us. And then we're going to try increasingly larger values for x to see what happens to the function and what is affecting the size of the function. So let's grab our calculators, because you certainly don't want to do this by hand. And if you look at this chart, this column is what we're going to input for x into the function. So we're going to try 5 and then 10 and then 30 then 100. And then if you look along the top of this chart, this is each of the terms from the function, the x to the fourth, the minus 9x to the third power, etc. And it's going to show what each of the terms gives us if we calculate just that term using this value of x. And let's look at the end of the chart first. Negative 4 stays negative 4 because we're not multiplying the negative 4 by x or doing anything with the input to the negative 4. So that's just going to stay the same. Let's work backwards from there. If I put 5 into the function for each term, when I do 7 times the 5, I get 35. When I do 10 times 7, I get 70. When I do 30 times 7, I get 210. And when I do 100 times 7, I get 700. So you can see that these values are increasing. Now if I put 5 in and look at just the negative 2x squared term, 5 squared, 25, times negative 2 is negative 50. When I put 10 in for x, 10 squared is 100, times negative 2 is 200. When I put in 30 for the x, 30 squared is 900. 900 times negative 2 is negative 18,000. And finally, when I put in 100, 100 squared is 10,000. Times negative 2 is negative 20,000. So I just did those three first because you can do those in your head. And you can see that this one doesn't change. This one gets increasingly larger, and this term gets increasingly smaller. Let's see what happens to the next term. When I put 5 in for negative 9x cubed, we can actually do it with our calculator if you want to just double check what's going on there. Negative 9 times 5 power up to the third power, and I get negative 1,125, just what we see in the chart. And then we'll replace that 5 for x with a 10, we'll get negative 9,000. Then with a 30, get negative 243,000. And then finally with 100, 100 cubed is 1,000,000 times negative 9 is negative 9 million. So this term is also getting increasingly smaller. But let's take a look at the first term, x to the fourth power. When I put in 5, let's actually do this one, 5 power up to the fourth power, I get 625. Now remember, you can always, in this calculator, I can go back and type over it. So I'm going to put 10. Well, actually that didn't work out so good, but we'll just redo it. 10 to the fourth power, and we can see that's 10,000. And 30 to the fourth power is 810,000. And finally 100 to the fourth power is huge. Let's see what that number is. It's 100 million. So the question is, which term in this polynomial is affecting the size of the polynomial the most? And if you look at these numbers, 100,000, negative 9 million, negative 20,700, and negative 4. Which one is sort of overpowering the polynomial? That would be the first term. It's affecting the polynomial the most. So that, when we look at the total, when we put each number into the entire function and get the total, this first term is really affecting the polynomial the most. First term gives us 100 million when we put in 100. The other two terms add or subtract some, but the overall effect comes from that first term. So when we are looking at polynomials, we can estimate how big a polynomial is just by calculating the first term, and that's something that you do in calculus quite a bit. You estimate the size of a polynomial by just calculating the first term.